Question 3, Part B. The circle in the diagram has center N. The line LM is tangent to the circle at P. Part 1. Find the equation of LM in the form AX plus BY plus C equals 0. To find the equation of a line or an interval, first we need to find the gradient of that line or interval. Then, using a known point on that line or interval, we can use the point gradient formula to come up with the equation of that line. So to find the gradient of LM, we can use the 2-point gradient formula. So that's change in y divided by change in x, otherwise known as rise over run. So x1, y1 represent the coordinates of point L. x2, y2 represent the coordinates of point M, and note that gradient's always measured from left to right. So the gradient of LM, substituting the values, we have 5 minus 1 in brackets divided by 5 minus 2 in brackets, which gives us 4 over 3 in fraction form. Now the point L, 2, 1 is a point on LM. Hence the equation of LM using the point gradient formula is y minus 1 equals 4 over 3 times x minus 2 in brackets. So that's y minus y1 is equal to m times x minus x1 in brackets. Now we could multiply the left-hand side by the denominator 3 to eliminate this denominator. So we get 3y minus 3 is equal to 4 times x minus 2 in brackets. Expanding the brackets on the right-hand side, we get 3y minus 3 equals 4x minus 8. Now I'm going to move the terms on the left-hand side over to the right-hand side. We want the equation in general form. We want the coefficient of x to be positive. So sometimes it's easier to move terms from the left-hand side to the right-hand side rather than the other way around, so that the x has a positive coefficient. So we get 0 is equal to 4x minus 3y minus 5. Therefore, the equation of LM is 4x minus 3y minus 5 equals 0. Part 2. Find the distance NP. Note that the perpendicular distance formula will be required to answer Part 2. The perpendicular distance d of a point x1, y1 from a line ax plus by plus c equals 0 is given by d equals the absolute value of ax1 plus by1 plus c over the square root of a squared plus b squared. NP represents the perpendicular distance of the point N from the line through LM. So using the perpendicular distance formula, where the line is 4x minus 3y minus 5 equals 0, which we found in part 1, and the point N has coordinates 1, 3, we have d is equal to the absolute value of 4 times 1 minus 3 times 3 minus 5 in the numerator over the square root of 4 squared plus negative 3 in brackets squared. And that evaluates to 2. Therefore, the distance of NP is 2 units. Part 3. Find the equation of the circle. The interval NP represents the radius of the circle with center N 1, 3 and radius 2. Recall that the equation of a circle with center h, k and radius r is given by x minus h in brackets squared plus y minus k in brackets squared is equal to r squared, which is based on Pythagoras' theorem, interestingly enough. Hence, the equation of a circle with center 1, 3 and radius 2 is x minus 1 in brackets squared plus y minus 3 in brackets squared is equal to 2 squared, or x minus 1 in brackets squared plus y minus 3 in brackets squared equals 4.